In this first video, we start NCEA Level 3 complex numbers by introducing what complex numbers are and how they are represented. If I talk about the whole course, this course is designed to prepare you thoroughly for NCEA external examination. This course mainly focuses on the merit and excellence level problem solving. For the complete structured course, continue learning on selflearno.co.nz. Dear students, today we are going to learn about a new type of number, and that is called complex number. Please take calculator and try to find the value of square root of negative 25. Definitely you will get an error. Please try to find the value of square root of negative 9. The same thing will happen. You will get an error. Do you know why is it happening? Because in the real number system, the square root of negative number does not exist. But now at level 3, we want to discuss about the square root of negative numbers. And that is why today I am going to introduce a new type of number system, and that is called complex number system. And the whole base of this complex number is square root of negative 1. It is accepted that square root of negative 1 is not a real number, but it is an imaginary number, and we denote it by I. So this I is nothing but an imaginary number. It is the square root of negative 1. So what I can say about I over here is, whatever the role played by 1 in the real number system, the same role is being played by I in the complex number system. Let me introduce some imaginary numbers. All the multiples of I are imaginary numbers, just like this 2i, 3i, 7i. These are imaginary numbers. Even negative multiples of I are also imaginary numbers, like negative 3i, negative 5i, negative 4.2i. These all are imaginary numbers. Even fractions are fine. 2/3 I. It is also imaginary number. So this is a bunch of imaginary numbers. My dear students, you very well know about the real numbers, even though I am listing it over here. There's 3, 5, negative 8, 7.2, 2 over 3. All these are real numbers. But the question stays over here. What do we mean by a complex number? Complex number. Yes, please get ready to learn something about complex number. If we mix this imaginary number and a real number by the process of addition or subtraction, we get a complex number. I repeat, if we mix this imaginary number and real number by the process of addition or subtraction, we get a complex number. Let me give you some examples. 3 is a real number. 4i is an imaginary number. So this 3 plus 4i is a complex number. This negative 5 is a real number. 7i is imaginary number. So this is a complex number. 2 is a real number. 5i is imaginary number, 2 minus 5i is a complex number. This 2/3 is a real number, but 2/3 I is an imaginary number. And the mixture of them by the process of addition or subtraction is a complex number. So now you know the structure of the complex number. It is nothing but the combination of real and imaginary numbers. So I'm going to introduce a standard form of complex number. Complex number. Generally, complex numbers are denoted by z. So here I accept z is equal to a plus ib. It is very similar to this thing. So this example, z is equal to 3 plus 4i, 4i, 4i or i4, whatever you can write. Okay, that is fine. So this is the standard form of a complex number. This complex number has two parts. This is real part and this is an imaginary part of that. So I can write here real part of z. The symbol is real part of z is a, and imaginary part of z I write like this, imaginary part of z is b. Now please be very cautious over here. This coefficient of I is considered as the imaginary part of z. In the imaginary part, we do not include this I. The coefficient of I is considered as the imaginary part. So, in this example, real part of z is 3 and imaginary part of z is 4. Let me give you some more examples of real and imaginary part of the complex number. Z is equal to 3 minus 4i. Then over here, the real part of z is 3, but the imaginary part of z is not 4, it is negative 4. Please mind this negative sign. One more example. Z is equal to, I'm writing it over here. Second, z is equal to 2/3 plus 2 over 5i. Here in this case, the real part of z is 2 by 3 and imaginary part of z is 2 by 5. Easy, but not always, Let us take this example. Z is equal to 5i. What happens over here? I want to find the real and imaginary part of this complex number z. See, in this complex number, there is no real part at all. We have only imaginary part. So here I can say that this is a purely imaginary number because it does not have real part in that. So if you want to write it, you can write in this way, 0 plus 5i. So real part of z is 0 and imaginary part of z is 5. So here we conclude that if the real part of a complex number is 0, then that complex number is considered as the purely imaginary number. Oppositely, See, the z is equal to 4. So in this complex number, there is only real part. There is no imaginary part at all. So I can say that this is a purely real number. That is why its imaginary part is 0. If you want, you can write in this way: 4 plus I times 0. So here real part of z is 4 and imaginary part of z is 0. See here, these are very tiny questions, but the concept is very important. We are going to use the same concept in excellence level questions. So let me write it over here. If the complex number is purely imaginary, then its real part is 0. And if the complex number is purely real, its imaginary part is 0. These two sentences are very important for you in many excellence level questions. So please remember these two sentences just like rules. So now I am going to introduce some properties of complex numbers. So first of all, I will just note down the standard form again. Standard form of complex number. Z is equal to a plus ib. So here the real part of z is a and imaginary part of z is b. So my dear students, we represent all the real numbers on a number line, right? We have 0 at the center and then 1, 2, 3 and all negative numbers over here. Integer, non-integer, decimal, all real numbers can be represented on a number line. But here, in this complex number, there are two parts, real and imaginary. So, to mention this complex number on a single line is quite impossible because it has two parts, real, and in addition to this real part, we have imaginary part. So a single straight line is not good enough to mention a complex number. So that is why we use a plane like this. And this diagram is called Argand diagram. Argand, let me write clear. Argand diagram. Yes. So in this Argand diagram, the horizontal axis is considered as the real axis and the vertical axis is called imaginary axis. See, I'm going to teach you two concepts altogether about Argand diagram, and one very important thing we are going to discuss over here is modulus of complex number. modulus of complex number z, we use this symbol modulus of z. We will discuss these also at the same time. Instead of using symbols, what I am doing, I am taking a numeric example so we can understand it better. Let us take z is equal to 3 plus 4i. So I want to represent this complex number on this Argand diagram. See, this horizontal axis is real axis. So the real part will be mentioned over here. And this vertical axis is imaginary axis. So the imaginary part will be mentioned here on imaginary axis. The task is very easy. So the real part of z is 3. And imaginary part of z is positive 4. Real part is positive 3. And imaginary part is positive 4. 1, 2, 3, 4. Perfect. So this real part is positive 3. Imaginary part is positive 4. We want to mention or indicate the position of this complex number on this Argand diagram. So what you should do, this point P, the position of point P indicates the position of this complex number on the Argand diagram. And the length of this line segment, let me call it OP. The length of this line segment OP is nothing but the modulus of complex number z. And you know very well how can we find this length of OP. We can use Pythagoras theorem over here. So by application of Pythagoras theorem, modulus z square is 3 square plus 4 square. Modulus z square or modulus z is equal to under root. Do not play in numbers, my dear. We want to understand the concept. Okay. So I'm keeping this as it is. And if you want, it is 5. And now please do not tell me that you should write plus or minus 5 over here. See how I defined this modulus of complex number. The modulus of complex number is the length of this line segment. And the length of the line segment must have positive value. That is why modulus of z is positive 5, even though we are taking square root over here. So we are not using the negative sign. And if I use symbols, then what will happen? Z is equal to a plus ib. So the real part of z is a and imaginary part of z is b. That means this 3 is a and 4 is b. 3 is a, 4 is b. So if I apply Pythagoras theorem over here in this right angle triangle, I get modulus z square is equal to a square plus b square. Let us take square root on both sides. Here, my dear students, please do not write like z is equal to a plus b. Square root of a square plus b square is not equal to a plus b. If two numbers are added or subtracted, you cannot take the square root of them separately. So, even though at year 13, I have seen many students, they make this type of mistake. Please take care. It does not happen. So now we have the formula. Modulus of a complex number is nothing but under root square sum of the real and imaginary part. Let us take one more example in which the imaginary part is negative. So we will learn something. The second example, z is equal to 3 minus 4i. That is fine. We are using the same type of numbers, 3, 4. It helps. So over here, real part of z is 3 and imaginary part of z is negative 4. So this horizontal axis is called real axis and this vertical axis is imaginary axis. So we will mention the real part over here and imaginary part over here. So the real part is positive 3. So that will come here on positive real axis. Imaginary part is negative 4. So it will come on the negative side. 1, 2, 3, 4. Great. So it is 3 and it is 4. I am not writing negative 4. Negative means on the other side. That's all. So the position of this point P describes this complex number z is equal to 3 minus 4i. And the length of this line segment OP, this length of line segment OP is nothing but the modulus of complex number z. And we want to find it. So over here, I can apply the Pythagoras theorem again. Modulus z square is equal to 3 square plus 4 square. So modulus z is under root 3 square plus 4 square. So you will get the same answer, positive 5. Even though we are taking square root, we have accepted the positive value only because the modulus of complex number is nothing but the length of this line. And the length of the line must have positive value. See this, if you will write this negative 4, it does not make any sense, The length of the side must have positive value. So how can you write negative 4 over here? No. This negative 4 means 4 on the other side. That's all. Let us use symbols. Z is equal to A minus IB. And then I can write in this way. So the modulus of complex number is nothing but under root a square plus negative b square. And square of negative will become positive. So ultimately we get this under root a square plus b square. So even though if you will apply this formula for this z is equal to 3 minus 4i, you are going to get the same answer. Z is equal to under root a square plus b square. So it is under root 25 and you get 5. But what I recommend is this is quite illogical, because this 4 is the length of this side. So I avoid to write negative number over here. But if you write it, you will definitely get the same answer. No problem. So at your student's level, it is fine. But my recommendation is do not use it. Let us try to find the modulus of some special complex numbers. If the number is purely imaginary, then what will be the modulus of that? If the number is purely real, then what will be the modulus of that? So in all the cases, I want to obtain the modulus of given complex number. The first, z is equal to 5 plus 12i. So modulus of z is nothing but under root a square plus b square, that is under root 5 square plus 12 square. You can use calculator, I will not, it is 13. Second, z is equal to minus 6 minus 8i. I want to find the modulus of this complex number. I can use the formula under root a square plus b square. So that is under root negative 6 square plus negative 8 square. So using your calculator, you will get the answer 10. So it is an easy process. Let us take the special example, a purely imaginary number. Z is equal to 4i. How can I find the modulus of this complex number? So you can think in this way, z is equal to 0 plus 4i. So modulus of z is under root a square plus b square. So modulus of z is under root 0 square plus 4 square. So using calculator or directly you can write z is equal to 4. But why will you waste your time like this? You should mean this, that modulus of 4i is 4, because modulus of I is 1. So if I apply this modulus z is equal to modulus 4i like this, modulus of 4 is 4, modulus of I is 1. So you get the answer 4. So I have seen most of the students, they directly come here. They don't follow this process. They want you to follow the direct process. The modulus of 4i is 4 because the modulus of I is 1. Furthermore, modulus of negative I is also 1. We can prove this. Just wait, it is just the beginning of the big concept of complex numbers. So many things we are accepting without proof, but during the flow of the whole course, I will be giving proof of each and everything, whatever we have assumed. I want to find the modulus of z is equal to negative 4i. Easy. Modulus of z. Modulus of negative number becomes positive. So modulus of 4 is 4 and modulus of I is 1. So you can write this answer directly. Modulus z is 4. Not a difficult task at all. So what you can remember from these two examples, if we have a purely imaginary number like 2i, then modulus of z is modulus of 2i is nothing but 2. Even whenever you get a negative number in front of you like negative 3i, so modulus of z is modulus of negative 3i, and that is nothing but 3. Modulus of I is 1 and modulus of negative I is also 1. Great. Now let us take one more example which involves some fractions. Z is equal to 4 minus 3i by 5. Perfect. I want to find the modulus of this complex number. See what we have. Z is equal to a plus ib. Modulus of z is under root a square plus b square. So I have to have this complex number in this type of standard form. Two parts, this real and imaginary, must be separated by the sign of plus or minus. So I have to separate these two terms. So z is equal to 4 over 5 minus 3 over 5. So now this is in this format. So I can use this formula. So modulus of z is equal to under root a square plus b square 4 by 5 square minus 3 by 5 square. So modulus of z is, you can use your calculator. So here I am not using calculator. 16 over 25, 9 over 25. So that is 25 over 25, that is 1. Square root of 1 is 1. Great. So to find the modulus of a complex number, you have to obtain the complex number in the standard form. Then only you will be able to obtain this modulus. In the whole chapter, it is going to happen. We are going to obtain the argument of complex number and many other characteristics of complex number. In all these cases, we need the complex number in the standard form. This standard form is also called as a rectangular form because it forms a rectangle over here. So it is also called a rectangular form. So it is just the beginning of a very huge concept. So whatever we have done today, just quickly revise it and get ready for the next class. See you then. Goodbye.